So I'm out here in Stony Brook. Earlier this evening, we were having some freezing rain. However, temperatures have warmed up to above freezing, so now we're having a plain rain. Temperatures are around 35 degrees right now with light rain. You can actually hear the rain falling on the snow. And there are big puddles everywhere from the heavy rain that came down earlier. Rain's getting a little harder now as we're getting a pulse of heavy rain that's coming in from the south. There are even some thunderstorms that are just off the coast that are coming our way. Just about a week ago at this time, we were expecting a snow and sleet storm. However, the track of the storm over the last couple days have trended further north. Just 3 days ago, we were actually forecasting freezing rain with temperatures not getting out of the 30s for today. However, we're going to see a high temperature later today of around 50 degrees, which just 2 days ago was unheard of. You were not supposed to get out of the 30s today. In fact, we were forecast to say below freezing just 5 days ago. The high temperature, according to the GFS and the GFS model, was only going to be 28. That was supposed to be the high temperature for today, just a few days ago. 28 degrees with not even freezing rain coming into New York City. That was supposed to say to our south. One of the models was actually almost forecasting an all-snow event with near a foot. However, the storm ended up going further west. However, the latest models I've been looking at, the European, was earlier forecasting a rain event for Tuesday, Friday into Saturday, but is now forecasting snow. Now they're forecasting snow for Friday, not rain. Rain is no longer in the forecast for Friday. It now looks to be an all-snow event with temperatures not even getting above 30 degrees. Just the last couple days, the models have completely changed. So it looks like there was a flip. We're going to have a snowstorm, then a rainstorm. Now it's going to be a rain event, then a snowstorm. So it's going to be rainstorm, then snowstorm. However, it's not going to be a lot of snow. The model is just forecasting about 4 to 6 inches. There's a little bit of ice here. It's still a little slippery. Looks like it's still a little chilly out. I'm going to currently check the temperature, but I think it's above freezing right now. Temperature's actually 40 degrees right now. Oh my gosh. There's very little steam coming out. Like, that's weird. Well, thank you for watching. Bye. Actually, before I go, it's currently actually 40 degrees. Not 35, but 40. I mean, it is chilly out, but it's bearable. This same system brought Dallas almost sub-zero temperatures and snow. Baton Rouge got a freezing rain event from this system. There was snow all the way. There was sleet and freezing rain all the way down to Brownsville, Texas. Brownsville, Texas even got a little bit of snow, which is... Keep in mind that Brownsville, Texas is at the same latitude as Miami, Florida. Almost at the same latitude. Brownsville, Texas, if you draw a line, if you go directly east to west, you'll end up in southern Florida around Miami-Dade County. That is how far south Brownsville is. That is literally on the Texas-Mexican border, right along the Gulf Coast. And they got snow. There was snow in Houston. There was even Gulf effect snow. There was even snow in the Gulf of Mexico because of the very cold temperatures. You know, cold air passing over very warm Gulf waters triggered Gulf effect snow. There was snow off the coast. There were even snow showers coming off the land because of very cold temperatures and slightly warm temps aloft, because most of the cold air was actually near the surface. Actually, no. So you had stratus clouds that formed snow. There was a little bit of snow on radar in Houston coming in from the northwest. Probably just flurries, but there was some frozen precip in Houston. Houston got freezing rain and sleet. As the storm pulled away, there was even a little bit of snow in the backside of the system. Even Brownsville was under a winter storm warning, and temperatures in Brownsville were 22 degrees Fahrenheit with even some snow. Imagine Miami, Florida being 22 degrees with snow. Imagine you're getting that perfect angled wind that would just shovel that cold air into Florida. But here's the thing, that probably wouldn't happen because you have the Gulf of Mexico on the west side and the Atlantic Ocean on the east, which moderates temperatures. However, if you get enough cold air and it passes over that warm water, especially if you get a north-northeast wind, you could get some ocean effect snow into Miami. But I'm not saying from this system. I'm just saying if you were to get a very cold outbreak, like a very cold pool aloft, you would get snow, and because there's some more convection, it maybe will be slightly above freezing, like maybe in the upper 30s, you would get graupel in Miami. Basically, it's not hail. Graupel is basically hail embryo. Hail forms from graupel, but graupel is snow, basically. Graupel is snow. It does not form in the same way as sleet, and graupel is not hail, but it's the precursor to hail. For example, graupel forms two ways. You could get it through convection, like you get hail because of a couple trips, or graupel is a snowflake that falls through a moist atmosphere. Like in a snowstorm, there was no thunderstorms or anything. There was graupel coming down. There was rimed snowflakes. And it was very cold out. It was in the low 20s. What happened was you had snow falling through a very moist environment, and that allowed the snowflake to get coated in moisture, in frozen moisture. Usually, graupel is either a sign of instability or a lot of moisture. If you get a graupel, it usually means there's convection. Or you can get graupel without convection if it falls through a very dense cloud, just because of accumulation of rime ice. That's two ways graupel can form. Graupel can form because of convection, like usually lake effect snow are notorious producers of graupel because lake effect snow showers are very convective, so there's a lot of convection involved in their formation, in the formation of lake effect snow bands, and therefore there could be graupel, even thunder snow. And if there's enough convection, you could even get, in rare cases, very rare, it's unusual though, you could get small hail in lake effect events, especially if it's in a late fall and say it's not cold enough for snow, but there's convection. You could get small hail, thunderstorms. Even on very, very rare occasions, it only happened once, but recorded, Reed Timmer recorded it. There was a lake effect, during a lake effect snow event, on one of the leading edges of the bands, because there was some wind shear, there was actually a water spout that came ashore and became a weak tornado. That's very unusual, but yes, you can get convection from instability, rather, during winter storms, especially lake effect. So let me get back to what I was talking about, is what's going on now. We're getting rain. So sleet forms differently from graupel or, from hail. Sleet falls as snow. It melts into rain as it falls down, right? Into a warm layer. So you have cold, layer of warm, maybe a few thousand feet thick, maybe 5,000 feet. And then another deeper layer of cold air below. And so it's raining in this warm layer, especially near the bottom of the warm layer. It's raining. It's probably in the mid-30s like it is here, around 40 degrees. So the snow melts into rain, but then it falls into another very deep cold layer, and therefore the raindrops refreeze, and you get frozen raindrops, aka sleet. However, in rare occasions, you can get hail mixed with sleet, rather from elevated convective thunderstorms. So it's very cold at the surface in the 20s, right? But then further up aloft, you might get temperatures in the 40s or even 50s, and then you have another cold layer above. And so this can trigger convection, elevated convection, that can cause thunderstorms. And if the thunderstorms are strong enough, with thunderstorms you get hail. And so you can get sleet, which is from the precipitation falling and the refreezing, and then embedded in the sleet, you'll get hail. So you'll think, oh, it's just big sleet, or all of it is hail. No. Sometimes you could get a mixture of sleet and hail. That actually happened in a severe thunderstorm in Oklahoma a few years back. So there was a thunderstorm that was in a very cold environment, and the surface, it was in the 20s. But there was thunderstorms aloft that had rain. You had elevated convection. And even though it was very cold at ground level, the lightning still hit the ground. You still had cloud-to-ground lightning. But there was no wind at the surface because, you had a very cold layer, separated from the warm layer. So all the turbulent air stayed aloft. Sometimes you could still get gusts of wind that would rush down to the surface. Like, there was even severe thunderstorms warnings being issued for these storms. On one occasion, for a freezing rain thunderstorm. The warning was for hail, not for winds. There was very little wind with those systems. And let me tell you about something else. That's the big thing I wanted to watch. There's actually a video I will link in. I will show you. Once I exit this video, I will link a video in the description that will demonstrate a sleet storm, cold air, elevated thunderstorm that had sleet and also hail. Well, thank you for watching. And just before I go, graupel, as I said, is hail embryo. Graupel forms normally in convective environments. You don't always need a thunderstorm to have graupel. Even not every convective cell will have thunder and lightning. Every thunderstorm is formed by convection, but not all convective cells will have thunder and lightning. For example, low-top convection rarely ever has thunder and lightning. For example, there was a tornado in New York City in the August of 2018 that hit Queens, just a couple miles away from me, very close to me. There was no there was no lightning or thunder for me to realize it was a severe thunderstorm in the area. There was no lightning. There was no hail. The only way I knew there was even a storm was because I got a tornado warning. And the tornado touched down about 10 minutes after the warning was issued. Not even all tornadic cells have thunder and lightning, especially low-top cells that are not ice-based. Like, you could have the top of a supercell, of a low-top supercell that'd be low enough that the tops are not even frozen. Therefore, you won't have, the ice, the ice that usually generates like thunderstorms. There was one time I was in Florida that I saw a very tiny cloud. Well, not tiny, but it was big, but I could see the base of it. I could see the tops of it. The tops of it weren't even over me, and the thunder was loud, like very close, like a mile or two away. This thunderstorm cell was maybe 15,000 feet. But there was some cold air aloft that day, and this little cell, despite being very tiny and very local, had a lot of thunder and lightning. And the environment was tropical, so you would think that the tops were, water. Apparently not. The tops looked heaped. There was no anvil that would indicate that it was cold air, but there was a lot of thunder. And I got some mist. I didn't even get rain. Apparently, I was getting the mist from the gust front. It got windy, but the heavy rain, I could hear it was in the distance, maybe 200 feet away. And storm rolled right by. And on radar, it looked tiny too. And they were saying, oh, we got a thunderstorm rolling off the ocean. And it was coming in from the east-southeast. And then we got other cells that came on that brought heavy rain. And I was hearing thunder, and I couldn't find where it was coming from. I'm like, Where is that thunderstorm? I went one way. I was apparently looking right at the thundercloud, not realizing that was the cloud. Because when I saw the lightning coming from it, I was shocked to find such a small cloud in a tropical environment at night, early in the morning, around 5 a.m., producing so much thunder and lightning. It just took me by surprise. There was no anvil. Like, there was no. The tops looked like it was still, the whole cloud was water based. I mean, it was a pretty darn big cloud, but it didn't cover the whole sky. And the fact I could see under it meant that the area of heavy rain was very small. I mean, yeah, there was definitely rain in the cloud because I felt the mist, that came from the gust front. So apparently there was enough heavy rain being produced that there was some mist coming off the downpours that were coming. Like, it was a mist. It was not even heavy rain. Oh, thank you for watching. Bye.